Hey there, and welcome to the Confident Chemistry Teacher Podcast. I'm Kim, your go-to chemistry coach for engaging teaching strategies and simple solutions to the everyday challenges chemistry teachers face. Let's get this reaction started. Hey everyone, welcome back to another episode of the Confident Chemistry Teacher Podcast. So just some housekeeping things. I just wanted to give you a heads up that I still do plan on doing my chemistry lab membership. Right now, our school is undergoing renovation, so all of our chemicals are still not accessible to us. So we haven't been able to do really any chemical labs this year. So then I obviously haven't been able to do any videos for you guys. That was one of the things that I wanted to include in the membership, along with the lab quizzes, answer keys, and then monthly meetings, and then community support. I'm planning on getting that going in January now because I was promised that our chemical cabinets will be accessible in the next month or so, and then that'll give me some time to record those videos and make sure that I'm ready to go in January for that lab membership. Another thing I just want to mention, maybe you can feel my pain. I told you guys I switched schools and I'm teaching a couple of sections of CC biology. And for us, that's some freshmen. One, I haven't taught biology in like 15 years. Two, they're freshmen and I am just struggling with their behavior. So why am I telling you this is normally whenever I release an episode of the podcast, I'll send you guys out an email with kind of a little summary, a little teacher tip, a little chemistry joke in it. And that's just one of the things I've had to put on the back burner because right now, I literally am making phone calls after school every single day and staying past my contract time, which is not amazing, but I feel like it's just something that I need to do to get a handle on things because I really want to nip this in the butt. I don't want this craziness to continue all year. So hopefully in the next few weeks, you'll see some emails coming out. I know some of you guys are probably like, I'm glad I don't have the emails. Well, you can unsubscribe if you feel that way, but just know that I do plan to get those emails going out. Well, what I have on tap for you guys today is I want to talk about this really fun lab that I like with my students. I call it the Isotope Marshmallow Lab, and it's something that I did not write, but I found on the internet, and I'm going to share the link for it in the show notes. You might want to go ahead and print it off or open it up before you start listening to the podcast so that you guys can see what I'm talking about, like the different parts of the lab. So the first thing I want to talk about is why do I like this lab? So the first thing is because I remember sitting in my chemistry class in high school. I don't know, I'm really old, but for some reason I remember this thinking, why do the words ion and isotope sound the same? And why are they have different meanings to them? So I like this lab because it does help the students see the difference, have a hands-on experience with isotopes. And then just a little teacher tip that I want to throw in there. I can't remember if I shared this with you before, is when we talk about the words ion and isotope, I tell my students to try to remember that ion is the smaller word. So it deals with the smaller subatomic particle, like the electron is smaller, and we've gone over these sizes before I give them this little way to remember. And that isotopes deal with a different number of neutrons, which are the larger subatomic particle or the larger word there. It helps the students visualize the number of neutrons that they're going to have in the different isotopes of the models they're going to build. I also like this lab because it deals with hydrogen. That's the models that they're making, the different isotopes of hydrogen. And I don't know why, but my kids always think it's so weird that hydrogen, when you just calculate it, doesn't have any neutrons. So I think this is a good way to show the kids hey, we can have an atom that doesn't have any neutrons in the nucleus. I also really like this lab because it has a short-ish reading passage. It's about 1 1/3 page, but the font's pretty big on it. And it just goes over some general stuff. What is an isotope? Why are isotopes useful? It gives them a couple of pictures of what different carbon isotopes look like. So in our school, there's a big push to do ACT prep. So I would consider this a type of ACT prep because they're having to read it and then they're having to summarize their findings there, which if you guys have seen the ACT, there's a lot of reading on there and students should get more familiar with doing that. I also like this lab because there's a couple of different spots for me to initial off or like sign off that they've done it correctly. Sometimes when kids do labs, they will mess up step one and then the rest of the lab is messed up. This is kind of one of those labs that could happen. So I like that I'm having to check in with each group before they move on to the next step. Now, the only time that this is a bummer is if I have really big classes. And when I just did it most recently, the most groups I had was 8. So that's awesome. That's perfect. But sometimes I've had really big classes. And mind you, I never do any groups bigger than 4. So like 3 to 4 is usually the group size that I do for this lab. Like doing it in partners would be amazing, but my groups are usually 3 to 4. And sometimes I'll have 12 or 14 groups. Making the sign-offs with that many groups in class is sometimes kind of challenging. And so that's just maybe something to consider is if you have that many groups, sometimes I'll skip the first initialing and then let them move on. I also like this because it's a group activity that's not a POGL. If you guys have listened to some of my other podcasts, you know that I love POGLs. I am a fan of POGLs, but any good tool can get worn out if you use it too much. So again, this is POGL-ish. They're working cooperatively to answer these questions, but it's not a POGL. And then finally, marshmallows. Come on, who doesn't like marshmallows? Kids are always excited when I have any labs that involve food. I do use the ones that are the small mini ones and they're colored. I think the set that we used had like pink and orange and green in it, but really as long as there's any different colors, that would work too. If you didn't want to use marshmallows, you could use something like those pony beads or something like that, I think would work. But I usually let the kids eat the marshmallows when they're done. So I would suggest 1 bag per class if possible. The kids only usually need about a half a bag to do the models in my classes. And so, my classes are between like 30 and 40 kids. But if I want to let them eat them, usually they need the other half the bag to eat. So that's just something to consider. And yes, I have students bring them in. I'm not buying them. Now let's just go ahead and go through this lab. So as I mentioned, it starts off with a reading passage, which makes a really great warm up if you don't have another warm up that you need to do. So they go ahead, they read that passage, they have a summary, and the box on the front page isn't very big. It's maybe really they're only writing 3 or 4 sentences in there. So again, it's not like a crazy long thing. It's accessible for all different levels of students. Then the next thing they have to do is they have to calculate the number of protons, neutrons, and electrons in the 3 different isotopes of hydrogen. Now, the thing that I like about this is they actually have to go back up into the reading passage and pull that information out of the reading passage. It's not like it just says like hydrogen 1, hydrogen 2. They're having to go back and find where was that in the passage and then write them down. There is a little teacher initial after that section, so I'll walk around and just initial that they got the right number for each of those. Then I'll have the students make their models. And so the way that I handle the materials is I have paper plates. I'll put, I don't know, somewhere between 6 and 10 toothpicks on the paper plate. And then I'll probably put like 1/3 of a cup of marshmallows on there. They don't need a ton. They only really need about like, I think it's like 9 marshmallows to do the lab. But again, I usually try to give them a few extra because I know they're going to eat some. So they go ahead, they make the models. I'll come around and initial when they're done. I'm going to be honest though, it's a rarity that especially my regular kids get it correct the first time. So the common mistakes that I see is that they just leave one subatomic particle off. Like they just don't include the neutrons or they don't include the electrons. And then the second thing that I find most common is that the students will shove all the subatomic particles together. So like the electrons are touching the protons or the neutrons. And then I try to give them a reminder about, hey, not all the subatomic particles are found together. Look back at your notes and figure out how you should be separating them. And so often I'll come back around and they'll have the model set up correctly. But if they still don't, I'll have them turn to the page where we did the model of the atom and I'll point out how the electrons are not near the protons and the neutrons. Then, like I mentioned, there's a sign off. Then the students are going to go ahead and draw models. Some of the students want to draw like the toothpick and marshmallow model, and I'm okay with that. Some want to actually draw the models of the isotopes like an atomic model, and I'm good with that. And then there's a few additional practice problems. I definitely can complete this even in my Chemistry 1 classes in about 30 minutes. So I like that this is kind of like a quick, easy, fun, physical, hands-on lab that kids are getting some more practice with isotopes. Now, in my ideal world, I'm also going to be going around and asking each group some like other questions that maybe aren't found in the handout. For example, I'll come around and maybe this doesn't sound nice, but I'll be like, hand the models to the person who has participated least in this lab. So they'll hand the paper plate over and I'll be like, hey, tell me which one's protium or deuterium, and like, why do you think it's that one? So then I'm making sure that everybody at the table is learning and understanding. Then I might be like, okay, now hand that paper plate to who's participated the next least. And then I'll ask them a question about like, what do you think is different between each model? Or where is the nucleus? Where is the electron cloud? I just try to keep everybody accountable, letting them know that they're all responsible for doing the learning. And those additional practice problems that are at the end of the lab are, again, pretty easy that students can complete. But again, they're getting the idea of what an isotope is. So I hope that you guys found this interesting. If you guys have any other labs that you want me to talk about, if you have any other topics that you want me to talk about, I would love to hear it. I want to be serving you guys and helping you learn stuff that you didn't know. And hopefully by listening to it as a podcast, and maybe you're listening to it on your way to work or whatever, it's just kind of like an easier way to find it instead of having to go search for it. So I'd love to hear your thoughts on this podcast and what your needs are so I can help serve you. Again, I want to remind you, I'm going to attach the lab in the show notes. Again, it's not my lab. It's something that I found off the internet, but I've been using it for years. And as I've said, I love it. So let me just leave you on this note, you guys. Keep experimenting, keep inspiring, and keep making your chemistry classes awesome. Happy teaching!